Welcome to the Explainer, everyone. Today, we're unpacking something absolutely essential if you're building robust, production-ready AI agents. We're going to master AgentScope Middleware. You can kind of think of this as your ultimate control board. It's the exact mechanism that gives you absolute, granular command over your advanced agent pipelines, letting you shape their behavior exactly how you need to. Now, if you've spent any time building complex systems, you already know this pain point all too well. You've got this beautifully functioning agent, but suddenly you need to add logging, or maybe you need strict access controls or trace data. And the mere thought of ripping open your core agent or model code to hard code these features, total nightmare, right? It creates clutter, introduces bugs, and basically ruins maintainability. Okay, let's dive into this because AgentScope has a brilliant solution.
That solution is Agent Middleware. So, what is it? It's simply the mechanism for injecting your custom logic, like detailed logging, complex tracing, input rewriting, or access control, right into the key points of the agent execution pipeline. But the real magic is the second half of that definition. You do all of this entirely without modifying the agent or model code. As we go through this explainer, we're going to trace the journey of a request to see exactly how middleware intercepts and extends agent behavior from the outside in.
Just to give you a quick roadmap, here's our agenda. First, the power of middleware. Second, anatomy of the hooks. Third, understanding hook types. Fourth, built-in tracing explained. And finally, building custom middleware logic. Let's get right to it.
Section 1. The power of middleware.
Getting started is actually incredibly straightforward. You literally just pass instances of your middleware directly into the agent construction using the middleware's list argument. Super easy. But the real power isn't just how easy it is to attach, it's how intelligently AgentScope handles them once they're in there. And this brings us to a massive win for performance: zero overhead routing. When you instantiate your agent, it scans each middleware instance you provided and checks exactly which hooks it actually implements. It then routes the middleware only into the matching, position-specific execution lists. Why does this matter to us? Because any unimplemented positions are automatically skipped. If your middleware only cares about logging the final reply, it absolutely will not bog down your fast inner reasoning loops. There is zero call overhead for skipped hook positions. It's so efficient.
Section 2, Anatomy of the Hooks. Now, what's really interesting about this slide is how AgentScope exposes this comprehensive arsenal of hook positions that cover the full path of execution. Let's walk through this spatial progression. You essentially have 6 main runtime hooks. At the very outer edge, you've got onReply, which wraps a complete reply, covering all your React rounds and tool executions. Moving inward, onReasoning wraps a single React rounds reasoning step. Then, if tools are used, onActing wraps a single tool call execution. Diving even deeper, onModelCall wraps the underlying chat model API call, literally the closest you can get to the raw model. We also have onCompressContext, which fires before reasoning when the agent decides if it needs to compress context, and onSystemPrompt, which fires when the prompt is assembled. It's a really complete toolkit.
To make this perfectly clear, let's visualize the actual execution order during a React loop. Step 1, onCompressContext happens right at the top of the round. Step 2, the onReasoning hook wraps the core reasoning process, but, and here's the critical part, embedded inside that reasoning step is step 3, onSystemPrompt, which fires right as the system prompt is actively being assembled. Finally, step 4, onModelCall fires off the actual API request. Seeing how these hooks nest within the agent lifecycle is absolutely key to knowing exactly where you need to inject your custom logic.
moving right along to Section 3, Understanding Hook Types.
To prevent any technical overwhelm, AgentScope neatly categorizes these hooks into distinct types. This categorization dictates exactly how multiple middlewares interact with each other, as well as the data flow. First up, we have the onion hooks, and I really want you to lean heavily into this onion analogy. Hooks like onReply, onReasoning, onActing, and onModelCall are all onion hooks. They wrap the next handler. So the first middleware in your list is the outermost layer of the onion. It allows logic to run before and after the inner layers, and importantly, it can observe intermediate event streams. On the flip side, we have transformer hooks like onSystemPrompt. These act completely differently. They form a sequential pipeline. They just chain from left to right, meaning the output of one simply feeds directly into the next. There's no inner layer concept here at all, it's just a straight assembly line.
Now, the third type is a bit of an outlier, but it's highly useful, the tool source hook, specifically list_tools. It's important to note this is an optional convenience interface. It essentially allows a middleware to advertise its own tools by returning a list of tool-based objects. But unlike onion or transformer hooks, it is not invoked automatically on the runtime path. The agent initialization doesn't just call this for you. Instead, you, the developer assembling the toolkit, must explicitly opt in by collecting these tools from the middlewares and passing them right into the toolkit.
Which brings us to Section 4, Built-in Tracing Explained.
As we all know, observability is critical for AI agents, while AgentScope provides a tracing middleware to wire the full lifecycle directly to OpenTelemetry. What you get straight out of the box is this beautiful hierarchical span tree for every single reply. You get a top-level agent reply span, which then nests down into a model call span, and, if tools are used, a tool execution span. The setup? All you got to do is register a tracer provider and an OTLP exporter in your process. Attach the middleware and boom, you instantly have professional-grade observability. And tying this back to our zero overhead rule from earlier, if no tracer provider is configured in your system, these hooks just short-circuit directly to the next handler. No spans are created, no attributes are computed, meaning the performance overhead remains virtually non-existent when tracing is turned off.
Let's look at the specific attributes captured at each level of this tree. The reply span grabs the agent name, session IDs, the input messages, the final output, and any pending tool calls. The nested model call span is where you track your tokens, the specific model provider, and the exact request and response content. It even wraps streaming responses perfectly. And the tool span captures the tool's name, the arguments passed to it, and the execution result. But there's an incredible detail here. If a tool is dispatched outside the agent, like an external execution, the tracing middleware synthesizes compensating spans to ensure you preserve full observability of those external systems. It's just incredibly thorough.
But you aren't limited to just what AgentScope provides. You have total freedom to trace your own custom operations within the agent lifecycle. You can simply grab a tracer scoped to AgentScope using the standard OpenTelemetry Python SDK and wrap literally any of your custom target code in a span. Because everything shares the exact same infrastructure, these custom spans are emitted right alongside the built-in spans and delivered seamlessly to the exact same OTLP collector.
Section 5. Building custom middleware logic. Let's move to and see how this builds.
All right, so we've talked theory and built-in tools, now let's write our own. The exact mechanics are refreshingly simple, which, if you're a developer, you know is a rare and beautiful sentence to hear. You literally just subclass middleware base. You then implement only the specific hooks you need, and you leave the rest completely alone. For the onion hooks you implement, they're going to receive an input_quargs dictionary. This carries the fields flowing into the wrapped layer. You simply execute your custom logic and then forward that dictionary by calling next_handler and passing those quargs. You can even pass keyword arguments here to actively override specific fields on the fly. And remember our onion layers. For streaming events, those inner middlewares will actually see those yielded events first before passing them up the chain.
To really spark your imagination, let's fire through some incredible practical use cases. Use case 1. Timing middleware. By wrapping the on_model_call hook, you can capture the start time, call the next handler, capture the end time, and log the exact lapse time of every single model API call. Super simple but utterly vital for performance monitoring. Use case 2. Rate limiting middleware. Also hooking into on-model call, you can check the time since the last API request. If it's too soon, you just use Python's time.sleep to pause execution before calling the next handler. This elegantly solves API throttling issues entirely from the outside without cluttering up your core reasoning loop with annoying delay logic.
Use case 3. Dynamic System Prompt Middleware. This one is a brilliant example of a transformer hook. By implementing onSystemPrompt, you can intercept the system prompt string right before the agent uses it, query a real-time database, or fetch the current date and time, append that fresh context right to the string, and return it. You automatically enrich the agent's baseline knowledge right before generation, every single time. It's a real game changer.
And finally, use case 4. Model fallback middleware. This perfectly showcases the ultimate power of decoupled middleware. By wrapping on-model call in a simple try-except block, if the primary model API fails due to an outage or a rate limit, your middleware catches the exception, swaps the model configuration in the arguments, and just retries the call using a fallback model. It seamlessly ensures production stability. How cool is that?
From tracking tokens to dynamically rewriting prompts to ensuring your system never goes down during an API outage, middleware gives you immense, elegant control over the whole shebang. So, considering everything we've looked at today, I'm going to leave you with this question. Which layer of the onion will you customize first? I highly encourage you to dive right into the AgentScope documentation and start experimenting. Thanks for joining me on this explainer, and happy building.